Modern enterprise billing environments ingest millions of transactional records, billable items, every single day. The sheer velocity of this data requires a highly optimized ingestion pipeline. SAP Convergent Invoicing serves as the engine designed specifically to absorb and process these massive volumes of disparate billable items. To handle this scale, the system processes these items in massive, uniform batch runs, rather than individual customized workflows. This creates a processing paradox. While the system requires uniform batch processing for speed, customers require vastly different final outputs. A telecom provider might need immediate clearing for private individuals, while requiring complex, hierarchical collective billing for corporate clients. A single batch run must generate invoices with distinct variations. Some require aggregated tax items, while others demand alternative invoice recipients or completely different print layouts. How does a single automated run execute these contradictory rules simultaneously? Achieving diverse outputs without breaking the efficiency of a single batch job is the core architectural challenge of convergent invoicing. System architects often assume they must hard code separate invoicing processes for every customer variant. This approach creates significant architectural bloat, making the system difficult to maintain as business requirements expand. SAP addresses this by using static master data to dynamically modulate the transactional process at runtime. The contract account is the specific master data object that carries the parameters for this dynamic modulation. Within the contract account, a single field modulates this behavior, the invoicing category. The invoicing category acts as an intelligent filter, allowing one transactional engine to output infinite custom variations based solely on a master data tag. The contract account is a unit that groups business partner postings for open item accounting. Before any document can be posted in FICA, a contract account must be assigned to the business partner. This circular diagram illustrates data stored at the account level. On the right, we see parameters like payment terms and account determination IDs. Below, we find billing controls like the collective bill account, leading to the parameter that triggers process logic, the invoicing category. Because these parameters live at the account level, they travel with the customer's data into every automated batch run they participate in. Convergent invoicing dictates how invoicing executes at runtime through a multi-level control framework. Layer 1 is the invoicing process, defined explicitly by the user when starting the run. It defines which source document categories are processed and enforces all mandatory invoicing functions. Layer 2 is the invoicing type, which the invoicing process proposes automatically. It reacts to the specific invoicing unit's composition and defines the menu of optional invoicing functions available for execution. Up to this point, both the process and the type are transactional parameters, agnostic to the specific customer. That leads to Layer 3, the invoicing category, transferred directly from the contract account. It acts as the final selector switch for the invoicing type's menu. Only accounts tagged with a specific category trigger the execution of those corresponding optional functions. This multi-level framework allows a rigid batch process to execute highly customized logic at the individual account level. Consider Telcom One, a company dealing with both private and commercial customers. Both customer groups must be billed in the same daily run, but they require vastly different invoice printouts and data lists. Telcom One creates two invoicing categories in customizing: 0001 for private customers and 0002 for commercial customers. Category 0001 is assigned to the contract account master records of all private individuals, while Category 0002 is assigned to the accounts of all businesses. During runtime, both Account A and Account B are swept up by the exact same invoicing process and invoicing type. As Account A is processed, the system reads Category 0001 and ignores complex optional functions. But as Account B is processed, it reads Category 0002, actively triggering the optional function to aggregate tax items and prepare a commercial printout. The final result is two perfectly tailored invoices generated without requiring separate batch jobs. By moving the logical fork in the road from the process configuration to the master data, Telcom One achieves scalability. Imagine designing this system without utilizing the invoicing category. It would have to build separate processes for private, commercial, and enterprise customers. Each new variant requires custom development and downtime. Contrast this with the streamlined architecture. A single robust pipeline handles the volume, while the invoicing category dynamically routes the data. The overarching process remains untouched, only the master data categories expand. This decoupling of billing logic from the batch processing engine allows FICA to scale across diverse business models without redundant infrastructure. Consider a private customer who upgrades their account to a commercial business tier. In a rigid legacy system, this transition would require IT to manually migrate the customer's data over to a completely different billing process. In Convergent Invoicing, a representative simply changes the contract account field from 0001 to 0002. In the very next overnight batch run, the system reads the new category and automatically applies the commercial optional functions. No back-end reconfiguration or IT intervention is required to change the processing logic. The invoicing category is the central mechanism that allows enterprise billing to scale dynamically, keeping architecture lean while satisfying infinite business requirements.